So today we're going to be doing 8.3, which is going to be arithmetic series. So we talked about arithmetic sequences on Tuesday, 8.1. Now we're going to talk about series. To go from a sequence to a series, you simply just add up all the terms of that sequence. Now that sounds easier said than done, because sequences can have infinite or very large finite sets of numbers, okay? But if we're looking at something super simple, such as the series or the sequence 3, 6, 9, 12, 15, and it's finite, we can simply find the arithmetic series by just adding up those terms. So 3 plus 6 is 9, 9 plus 9 is 18, 18 plus 12 is 30, 30 plus 15 is 45. So in essence, a series is just adding up the terms of a sequence. All right. So these are the formulas you're going to need to use for arithmetic series. All 4 of these formulas are going to be essential for you when you're taking tests or quizzes on this unit. So just make sure you know where to access them. So these 2 rules, the general rule and the alternative rule, they do the exact same thing, but you use them interchangeably based on the information provided to you in the question. So as you can see, if you know n, a1, and an, you can find the sum. Or in this one, if you know a1, d, and n, and you don't know the last term, you can find it as well. So it just depends on what information they give you. Now, oftentimes, you're going to be often missing one piece of information, so that's where these other 2 formulas come in, okay? These other 2 formulas, this formula is literally just the arithmetic explicit rule you've all seen before, and this one over here is a manipulation of that, which will help you find n or any of the missing information. So let's look at number 1 and see what we can figure out. In number 1, what is the first term of this series?
7.
Good. What is the common difference between the terms? 4. The reason it's 4 is because every time it's going up by 4. Does everyone see that? And then next, we want to know how many terms there are, but unfortunately we don't know what that is because these dot dot dots right here tell us there's some amount of terms in the middle, but we don't know how many there are.
Do we just have to sum?
So we do have a way to figure out, and I'm going to show you what that is. So what is the last term of this sequence? We call this by the letter an.
223.
Good, 223. Okay, that's the last term. So, if we want to find n, we can find n by using this formula right here, because we need to know n to do the general or the alternative rule.
When do you know which formula to use?
Based on what information you have.
Oh.
So sometimes you don't have enough information to use one, sometimes you do. Okay. So n is equal to your last term minus your first term over d plus 1. Okay, that's how you find n. So I'm using the formula to find n. So if we do that calculation, you should get 55. Okay? So now that we know what n is, we can now move on to what the actual sum of this sequence is.
What does n mean?
The number of terms.
So there's 55 in between 15 and...
No, there would be 1, 2, 3, 4, 51 between that. Because that makes a total of... The dot 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 means there's some amount of terms between them. But we can figure out how many based on that formula. So now that we know this information, we actually have enough information to use either formula. Either formula is going to give you the correct result, but when I have the option of using both, I go with this one because it's easier. You know what I'm saying? So, the sum of the first 55 terms, that's how we say it, in this case all of the terms because it's finite, is equal to 55 divided by 2 times the first term plus the last term. And if you do that calculation, you should get 6,325. Okay?
You know, it looks a lot more complicated than it actually is.
Exactly. That's the thing with these explicit. All the formulas look complicated because you're not used to seeing subscripts and superscripts and all that. But it's actually really a simple concept once you get the hang of it. All right. So let's move on to number 2.
Can you stay on that slide for just a second? So I can-
Yeah. You ready?
Yeah, just a few more seconds.
All right, next problem. So in this case, we didn't get a preview of the series, but we do have N, A, N, and D. Now what you're going to notice about the 2 formulas is both formulas require you to know A1, the first term. Does everyone see that? So unfortunately, we're going to have to figure out what A1 is before we can use either formula. So in that case, I'm going to have to use one of these formulas to find A1. Now, we have the ability to use either formula. I usually will go with the one that doesn't have a fraction if I can avoid it. It's just more cause for error. So I'm going to take this formula right here, and I'm going to be plugging in for those things. So the last term is equal to the first term, which we don't know, plus N, which is 16, minus 1 times D. So you see how I plugged in everything I know into this formula right here, so that I'm able to find the one thing I didn't know. So if you do the math, this is going to come out to be 120. That's just 15 times 8, which is 120. And then how would I lastly solve for A sub 1?
Subtract 120.
Good. Subtract 120 on both sides, which is going to give me A1 is equal to 120. So now that I know what A1 is, I have the option of now plugging into either formula. Because see how I have enough information to use either one. Like I said, will go with the general rule if I have the option because it's easier and less room for error. So the sum of the 16 terms is equal to N divided by 2 times the first term plus the last term. So the sum of the first 16 terms is equal to 360 times 8, which is 2,880. So do we have any questions about that? Yes. You got it?
Yeah, just like
Okay. All right, so moving on. Yeah. All right. So now we're going to talk about this new notation. It's called a summation in math. You've probably seen this around, like, seeing just on movies or whatever, they'll use like fancy math and make it look like it's something complicated and they'll throw this symbol in there. This is an uppercase sigma in the Greek alphabet. And we use this to denote repetitive addition. That's why it's called a summation.
On the calculator, it has like that sigma symbol with a plus next to it, and just like, I don't know exactly what it is.
Oh, yeah. Yeah, it
But
does.
In like 5th grade, my friends and I would like press the button over and over again to race to see who would like get to 100 first or something.
Yeah, that's exactly what, it's just repetitive addition.
I don't have it at all on mine.
You don't need to know to use that button though. But yeah, it does have one on it. We're not going to use it though today.
I missed
at all.
that when it was built in
I know, you don't need to know it though. I've never used it a day in my life, don't worry. Okay, so basically how this is set up, this right here is going to be the term that you start on, and this is going to be the term that, how many terms you're adding up. So
what do you mean the term that you start with?
it's going to make more sense when you see an example.
Okay, great.
Yeah, in theory, everything's more confusing. Yeah. So this right here represents the explicit rule. This is what you learned about in 8.1.
I'm so sorry, what's N again? like the n above the sigma symbol?
Which one?
The one above. The
Oh, that's the upper limit. Throwing me off my game here.
Oh, yeah.
So, let's go ahead and look at an example of one of these. I think that will make it more understandable. So this is a summation. So this is the rule for the summation. So what happens is, this is the first number you plug into that summation, the bottom one. You see that right here? You're going to plug that number in for n, and you're going to get some answer. You see how here I took and I plugged in 1 for n, and I got 1. You're going to hold on to that, okay? What's the number that comes directly after 1? 2. You're then going to plug 2 into the summation, and then you're going to calculate, and you're going to get 4.
So,
What?
this is so confusing to me, sorry, but you have that sigma symbol, and then you have this equation, right? Like
I haven't addressed what the sigma symbol does yet,
Okay.
so I will address that. So all you're doing is you're plugging in the following number each time, okay? So the number after 2 is 3. You plug 3 into it. Then you plug in 4. Then you plug in 5, and you're solving each one of these,
What are
okay?
you plugging it in? What are, like, those numbers in the bottom?
You're plugging it into this right here.
Okay, for n?
Yes. You see how I'm doing showing the work of plugging it in for n in each one of these?
Yeah.
Okay.
So then those numbers in the bottom are what you would get?
That's correct.
Okay.
Exactly. That's the calculation. Now I stopped at 5 because the upper limit is 5. You see that?
Mm.
I see,
So
alright.
you're plugging each one into, that equation next to the symbol. What does the n equals 1 have to do with anything?
That's just how they write it. It's weird, but that just means you start. That's the first number you plug in. Because you could start on 2.
You start with 1?
You start with 1. If it had 2 there, you'd start on 2. If it had a 3, you'd start on 3. You plug in numbers until you get to the number at the upper limit.
Got
I see.
it.
Okay? Then the whole summation comes in because whatever you get for those calculations, you're going to add together. Okay? So in this case, I got 1, 4, 7, 10, and 13. I add those up, and that equals 35. So that's the sum of that series. Does that make sense? It's so simple, but it's like a new concept. So I know it's sometimes hard to wrap your head around, but that's what a summation is doing effectively. Okay?
So, is it possible that the summation will ever be like incorrect or something? Like you get, it says it equals 35, and then you add all the stuff up and it doesn't?
No.
No.
I
So,
mean,
like,
that
how would
there's
you-
always a chance of a typo,
So,
but they're not going to tell you that.
yeah.
You have to find that.
Oh, I see.
Yeah, you're doing that math yourself. But here's the problem with this method that we use. We use summations for other things as well, in like calculus. But here's the thing: what if the upper limit was 63?
You don't want to write them all out.
You don't want to have to write them all out, but we see that it has a pattern, right?
Mhm.
Do you see the pattern that's happening here for each one of these? It's going up by what each time? 3. So because we have a pattern, bless you, because there is a pattern, what we have is the summation or the sum formula. So I'm going to talk to you about how we can write a summation and then how we can use the sum formula to speed up the process. Okay? So, bless you. First thing we're going to do here is I'm given a series. You see that arithmetic series. First thing you want to identify for that series is what the first term is, which is? Good. Next thing you want to determine is the common difference. I don't know why I put a 1 there. Which is what?
4.
Good. Everybody see why the common difference is 4. It's going up by 4 each time. And then a sub n represents your last term, which is what? 207. Now we don't know what that last term is yet, so we don't know what n is, but we do know that the term itself is 107. We don't know what position it's in. We don't know if it's the 28th position, the 18th position, because we don't yet know how many terms there are in this thing. So we have to figure that out first. So we have to determine n. Now fortunately, we have a formula for finding n, don't we? On the top of your notes. So we're going to apply that formula to find what n is, because we have enough information to use the formula. So n is equal to
Which formula are we using?
the one that n equals. Because if I want to find n, I want to use the n equals formula.
Okay, yeah. I think I know what that is.
Okay. So I'm going to take the first term, the last term minus the first term, all over D plus 1. So N should come out to be, I think it's 51. 51. So, now I have A1, I have D, I have AN, the last term, and I have N. Now we know that now the last term is the 51st term. Okay? We know that information now. So, next thing you want to do is you want to create an explicit rule. So this is taking you back to what we did in 8.1. Simple times. Okay? So, all we do is I write out the formula for an explicit rule. You remember this from 8.1? And in 8.1, all we ever plug in for is A1 and D. Always. Okay? So I'm going to plug in those two things. So I know that AN is equal to your first term plus D. I'm going to write the D out front because it's just easier to distribute. Okay? Now I'm going to make this as simple as I can by distributing. This is the first thing we did in 8.1. And then I'm going to combine like terms. So I get the rule to be 4n plus 3. So this rule will give you any term in the sequence, right? That's what we just came up with. So now let's go ahead and write our express it as sigma. You'll see the terminology express as sigma. This is sigma. That's your summation. Okay? How you do that is you get whatever the explicit rule is and you write that here. Now what's the only thing we're missing on our sigma? The upper limit. The upper limit is denoted by n. So it is 51. So that's how you do it. Okay. Next thing we're going to do over here is we're actually going to evaluate one of these. Now, if it starts at 1 and the upper limit is 18, how many times would we have to be plugging in here? 18 times. That's a bit much. So I'm going to show you an alternative. Okay? I have napkins because we ran out if you want one. So, first thing we need to determine is our n. So if we look back to the last one, we see that whatever this upper limit is your n. Okay? Okay. Anyways, okay. That's okay, you just scared me. I was like, what's going on? Okay, so your n is 18, and now we're going to find the first term. So, how you find the first term, if you don't know it, is you plug 1 into this right here. So you're going to plug in 1 for k. So that's going to be 6 times 1 minus 1. So your first term is what?
5.
Good. So we always know that we have to know our first term and our what to find a sum. First and last. So to find the last term, a sub n or a sub 18, you're going to plug 18 into the formula. And that's going to give you something. 107. Okay. So, now we know n, our first term, and our last term. Can we find the sum of the terms now? Using the first formula on your formula sheet, general rule. So the sum of the 18 terms is equal to n divided by 2 times a1 plus an. So S is equal to, that's going to come out to be 1008. So had you went ahead and just plugged in 1, 2, 3, 4, 5, 6, 7, 8, all the way up to 18 and then added them together, you would have also got 1008, but this is a little bit quicker. Okay?
Will we ever have to, like, on the homework, do that, write them all out?